Practice set 16. For each problem, solve for the missing dimension. Use examples 49 through 53 for reference. In problem number 2, we will start with the reference angle. And since we're looking for angle A, we'll use that as our reference. We'll label the sides of the triangle, always starting with the longest side. The side opposite the right angle is our hypotenuse. Through the triangle, our anchor, that means this side here we'll call opposite, and the third side is the adjacent side. We're going to keep dimensions that we know to help us solve this problem, and since we don't know anything about the adjacent and we're not looking for it, we'll discard that. We know the lengths of the opposite and the hypotenuse, and using the mnemonic SOH CAH TOA to help us remember the ratios for the three trig functions that we're using, we'll look at what we have and determine which ratio to use. Starting with the SO part of this, S for sine, is the ratio of opposite over hypotenuse, and that's exactly what we have. So we will use the sine ratio to solve for our missing angle. Sine of an acute angle in a right triangle is the ratio of O for opposite over H for hypotenuse. Plug in the numbers that we know the value of. We will put a 1.5 for the opposite side length and a 3.0 for the hypotenuse. Simplifying this equation, we'll do the indicated division by taking the numerator 1.5 divided by the denominator of 3 and recording the decimal equivalency, which gives us 0.5. To get to our angle A, or have angle A by itself, we need to undo the sign. To do that, we will take the arc sine, which is the inverse function of sine. What we do to one side, we need to do to the other side. So we will take the arc sine of the right-hand side as well. The arc sine of sine leaves us with angle A, and the arc sine of 0.5 using our calculator, and most likely using or seeing sine to the negative 1 to symbolize the arc sine function, will give us a value of 30 degrees when we use our calculator for the measure of this acute angle. In problem number 4, we're looking for the value of the side designated by X. We'll identify the reference angle, and since they're giving us the measure of this acute angle, we'll use that as a reference angle, labeling the sides of the right triangle, starting with the longest side, the side opposite the right angle. We're trying to determine the length of the hypotenuse. With A as our reference angle here, we'll label the opposite next and the adjacent side last. Since we don't know anything about the opposite and aren't looking for it, we'll discard that. So we have information about or are looking for a value of either adjacent and hypotenuse. Those will be the two sides that we'll use. Going to our SOH CAH TOA, our mnemonic for the three trig functions or formulas that we use, we'll look for the ratio that uses adjacent and hypotenuse. S for sine is opposite over hypotenuse. That's not going to do us any good, but cosine C, AH for adjacent and hypotenuse, is the ratio that we will use to solve for our missing value. The cosine of an acute angle in a right triangle is A adjacent over the hypotenuse ratio. We know the angle measurement for this problem, so we'll replace A with 55 degrees. adjacent side is 16, and the hypotenuse is what we're looking for. To solve this problem and to eliminate the denominator to start with, we will multiply both sides by that denominator value, or x. We'll leave the left-hand side as is right now. On the right-hand side, an x factor in the numerator cancels out an x factor in the denominator, since x divided by x is 1. 16 times 1 divided by 1 is 16. To get x by itself, since it's being multiplied, we will divide both sides by the cosine of 55. Cosine over cosine on the left-hand side, since they're the equal values, cancel one another out, leaving 1. 1 times x is x. And using our calculator, we'll start with the numerator value 16 and divide it by cosine of 55 degrees. Be sure you hit an equals to simplify that right-hand side, and we should find a value for x, our hypotenuse, of 27.9 for the correct answer.